Okay, this is a graphical question about SHM. I think it looks initially quite complicated. However, we're going to see how to do it. As ever, I suggest you try the question first. You could be using this video if you have a copy of the question in front of you. And if you're ready to watch the explanation of the answer to this, then feel free to continue watching. So we've got a displacement time graph, and we're showing how that works for an object of undergoing simple harmonic motion. We're noticing the amplitude is consistent, and as is the period, as we'd expect. Now, for answering this kind of question, you might be tempted to look at some of the more complex equations in your datasheet. However, you don't need to. All you need to do is remember, again, and I think we've used this in previous questions, that for an object undergoing simple harmonic motion, we have a equal minus omega squared x, where omega squared is a constant. Now, why is that important? Well, it means we can analyze our graph. Let's take, for example, when x is equal to 0. Well, it must be the case that a is equal to 0 at that point as well. Any of the graphs that we are going to choose here must show a equal to 0 when x equals 0. Now, the easiest one to look for is at time equal to 0 in this case, because you notice on here we have time equal to 0, x equal to 0. If we then look at graph A, we notice that A is not 0 here, and so therefore graph A cannot be my answer. If you could spot another one, graph B is also non-zero, and therefore they cannot be the answer as well. So therefore we can actually rule those two options out. We're left with two more. Well, you may sort of be able to see the direct route here, but we can take this step by step. This means that if a is greater than 0, x is greater than 0, a must be less than 0. Okay, and therefore if we compare our graphs, hopefully you can see here, for example, that we've got a greater than 0 x. Well, and notice at the same time, a is also greater than 0. And so therefore that is also not a solution. C is not a solution. And again, it's got to be the case. The inverse got to be a case, x less than 0, a greater than 0, and that is very much shown by our option D. Now, HL students may be able to use equations more comfortably to look at this. Okay, SL students simply have to match up and use that guiding equation, a equal to minus omega squared x.